Hello, today we're going to explore ionic charges. In this video, we'll see how to create a net negative charge using just a balloon and our head, and also how the negative field present on the balloon influences a previously neutral salt and pepper mixture on a plate. By the end of this demonstration, we'll hopefully have a better understanding of what forces are involved in this demonstration and what's actually causing the salt and pepper to move or to stay. So first off, let's talk about hair. What's going on there? Well, hair has a naturally negative charge, which is insulated by a protective lipid bilayer. So that's undamaged hair. Damaged hair has that lipid bilayer or lipid layer, not a bilayer, lipid layer removed. And so the negative part is exposed, and that is what causes the higher negative charge in more damaged hair. And so this is why you see more frizz or like flyaway hairs in people with more damaged hair. It's more difficult to style and more difficult to control. And so that's why I blew dry my hair without brushing it, specifically for this demonstration, hoping to damage it as much as possible before doing this demo. And so when you rub a balloon against your hair, some of the electrons from your hair are transferred to the balloon, giving it a net negative charge. This is also sometimes called static electricity. So once we have our negatively charged balloon, we're going to hover it over a mixture of salt and pepper, which, as far as I know, has no charge. It's neutral, and we're going to see what happens. So let's give this a try. Okay, and we're back. So we have our plate of salt here, and we have our balloon here. We have hair here, and we're going to rub the balloon on the hair vigorously for a couple minutes and see if we can get a net negative charge going, and then apply it right above this salt and pepper mixture and see if we can get any movement. So let's go ahead. All right. So we got some pepper and a tiny bit of salt. Very tiny though. We did get some pepper. Great. Okay. Oh my gosh. Okay, so the pepper stuck to the balloon, but the salt did not. What is going on here? How did a negatively charged object attract pepper, which has no charge? So it turns out that substances and materials can not only carry a charge, but can separate out into positive and negative poles. This is called electric polarization. And it occurs when an electric field distorts the negatively charged cloud of electrons around a positively charged nuclei in the opposite direction of the field. So this shifts the charge on the salt and pepper to be in the opposite direction of the balloon, or in the positive direction, and the pepper jumps up because of this. So the salt is also positively charged, but because of its weight and density, it stays behind on the plate. If we had a stronger negative field, we might be able to overcome the force of gravity on the salt. Okay, so I think I got it now. So when I move the negatively charged balloon over the mix of salt and pepper, the net negative charge polarize both the salt and pepper, so the positive pole is facing towards the balloon. The pepper is light enough to be lifted by the electronic forces, but the salt stays behind because of the higher density. Okay, got it.